Okay, this video is going to be dedicated to 26 through 30. I'll loop back around and pick up the ones I missed in between there, but starting at 26 for now, this is all on random variables that are continuous in probability distribution functions. So continuous distributions, essentially. So it says 26, consider the function f of x is equal to x on the interval 0 to 2. And it says, does this admit a probability density function on the interval 0 to 2? And so what we need to find out, in order to have a valid probability distribution, if we take all the probabilities, we add them up, they should be 1. Now if we have a continuous form, it looks like this, from A to B. Now for us, our integral, right, and it should be equal to 1. Now for us, we have 0 to 2, we have x dx equal to 1. I'll show both ways. You can do this by hand, right? This is just a reverse power rule. So if I add 1 and divide by the same value, I plug in 2 and 0. Well, if I plug in 2, I get 2 squared divided by 2, I get 2. If I plug in 0, I get 0. And so I end up with 2, which we can see is not equal to 1. Right, so that's the way if we wanted to do it by hand. If we wanted to check it using the calculator, let's see if I can do this quickly here. Finish. And let's pull back our OneNote. Ooh, I gotta do this, that's why. There we go. Let's see, math. Let's see, probably under calculations, I would guess, yeah, fn int. Enter. 0, enter. Oh, I gotta push the up arrow. Let's clear this out, let's try again. Math, all the way down to fn or function integral. We have 0, push the up arrow, we got 2. Side arrow, we want to get the x, and then we want to integrate this with respect to dx. And that should give us, yep, same thing, 2, right? And again, we need to know the definition here that we're looking for it to be equal to 1, right? So we know that this is not a valid probability distribution, or PDF. Okay, 27. I think it's going to be very similar. It says determine the value for k, so that f of x is a probability density function on the interval 0 to k. So in other words, if I have 0 to k and I have 5x dx, it should be equal to 1, and we want to go solve for what k is. So similar, in this case we can't use a calculator because the unknown here is in the actual integral itself, or in the bounds itself. So 5x squared divided by 2, same reverse power rule, we add 1 and divide by that same value between k and 0. If I plug in k, it's just going to take the place of x, right? And if I plug in 0, right, I'm going to get 5 over 2 times 0 squared, or in other words, 0. And so we have 5 over 2 k squared is equal to 1, right? This statement needs to be true. And so we have k squared is going to be equal to 2/5, which means k is going to be equal to the positive square root of 2/5. So there is our k value. Very common question, normally solving for k. Probably 28 is even a more common question when you have an unknown k that you want to solve for. It says find the value of k for which the given function, the probability density function, f of x is equal to 8k on the interval -2 to +2. I mean, you could use this calculator. You could use the calculator here if you wanted to. This whole 8k, 8 is obviously a constant, k is a constant, right? So when you're setting this up here, we still have this same thing. It's supposed to be equal to 1. But because they're both constants, really you could just, this is 8k, and if you wanted to do this in your calculator, you could write this as just a 1 here. Oh, I forgot my dx, didn't I? dx equals 1. If you don't want to use your calculator, right, you could just go about this. A 1 just goes back to x. So now you have 8kx between 2 and negative 2. If I plug in 2, I get 8k times 2. If I plug in negative 2 minus 8k times negative 2, and yeah, you could have just held off on the 8k if you wanted to. 16k minus a negative 16k, so another 16k, and this whole thing is supposed to be equal to 1. So 32k equals 1, or k equals 1 over 32. Let's see, so I think that looks like all the k questions. That was 28. Let's look at 29. So the grade point averages of the Gourmet Society are uniformly distributed, right? So anytime we have a uniform distribution, we're thinking of this rectangle here. And it says between 2.5 and 3.5. It says find the probability density or distribution function for f of x. So for uniform distributions, the probability density function, probability distribution function, either way, is equal to 1 over b minus a. Now in your case you have 1 divided by 3.5 minus 2.5, and so it's 1 over 1. So just 1. And this is for part A. And so it says, using part A, find the probability that the randomly chosen member of the society has a grade point average between 3 and 3.2. And so rather than do, right, you could just essentially look at areas of rectangles here. I know that the area of this rectangle, right, it's actually just a proportion. So if I take 3 and 3.2, let's say randomly somewhere in here, and I know the whole space between 2.5 and 3.5 was 1, and I know the space between 3 and 3.2 is 0.2, well then I just get 0.2 as my probability. So just looking at the proportion of the interval we want based on the total interval of the entire uniform distribution. That was B, sorry. So now we're on to 30. So a shorter video for this one. Suppose a website is losing its membership continuously at a rate of 5% per year continuously. So we know anytime we see the word continuously, we have this. So we're looking at an exponential distribution, and it has negative 0.05 per year. We'll use the variable t. Using a suitable density function, calculate the probability that a randomly chosen member will be lost in the next 4 years. Okay, so what we need to know about I'm going to highlight this for right now. What we need to know about a exponential distribution, there's a couple different ways of writing it. You can use, there's a theta way and a gamma way. I'm going to use the gamma because it's a little easier for us. It has this form. Did I say theta and gamma? Lambda, sorry. Lambda equals, so we have lambda e to the negative lambda x, right? So rather than going and having to solve for that k, it actually is just the lambda that you have there. So our function is equal to 0.05 e to the negative 0.05 x. And so now, if we want the first 4 years, we're looking at the integral between 0 and 4 of 0.05 e to the negative 0.05 x dx, and it actually works out really nicely, right? Because what happens here, if we did this by hand, we would see it. When we integrate, we have 0.05 e to the negative 0.05 x all divided by, because of our, I'll write this short rule over here. This is going to be e to the nx over n. Of course, there's a plus c, but we don't really need that right now for indefinite integrals. these will cancel each other out, and we're left with e to the negative 0.05. And we're trying to evaluate this between 0 and 4. So if I plug in, oh, there should be a negative sign, sorry, right? We're dividing by a negative. So there should have been a negative down here that we still get. Almost messed up. So we have negative e to the negative 0.05 times 4 minus a negative e. And if I plug in 0, I just get 0. And so this ends up being, if I simplify, negative e to the negative 0.2 plus 1. Or in other words, we can rewrite this as 1 minus e to the negative 0.2. So I'll do that on my side here, and then I'll show, right, we can obviously plug this whole thing into the calculator as well, if that is a method you can use. Looks like I got 0.181. 0.181. Let's verify, and then I'll show you how to use the calculator if you want to use the calculator on this one. 0.813. He wants 4 decimals. Yeah, they want 4 decimals here. Okay. So if you want to use the calculator, last thing for this video. So it's still the same idea, right? Let's go ahead and clear all that. We'll go to math. We'll go back down to our function integral. We're going to say for us, our bounds were 0 to 4. And we'll use x, I guess, that's fine. So we have 0.05 second. We're looking for the e, which is hiding under the natural log. There we go. To the negative 0.05x dx. And perfect, 0.1813. All right, so both ways of doing it. That was problems, let's see, I think 26 through 30. I think that sounds right. So I skipped over 22 through 25. I won't forget, that'll get posted soon, but at least this is another video for you to watch. All right, see you in the next video.